Hey everybody, and welcome to our next video for food chemistry, which is all about dimensional analysis. So before we talk about what dimensional analysis is, what I want us to look at is just this recipe. So I found this recipe and it's for a cacio e pepe, some type of bread, right? And love good cacio e pepe. I went to Italy actually a few years ago with my family and I had some there and it was so good. So I always make sure I get it when I can. But this is some bread recipe and it's just got, some sort of cheese and pepper. And here's the recipe. And because this is a relatively European style of consuming some types of, breads and pastas and all that, this is all in units that I don't know how to use those in my kitchen. So when somebody said to me, or if I look at this and it says you need 250 grams of flour, I would go, I don't know how much that is. I got to get my scale out. I got to do all this stuff. There's an easier way, or there is a way to get these particular units into our units that we are most comfortable with. So what we are going to do is some dimensional analysis and convert some of these units that you see here on the screen that we are not as familiar with measuring, and using that to convert it to units that we are more comfortable with measuring here in America. We use the cup. We don't bake by mass here. You might if you're a pastry baker. I think it's much more accurate to bake that way. But anyway. So let's get into it. So we are going to use this process of dimensional analysis. And dimensional analysis is a problem-solving method that's used to change one unit of measurement to another unit of measurement. So dimensional analysis always sounds really scary, but in fact, it's not that scary of a phrase. It's just the method that we're using. We're using dimensional analysis in order to convert from one unit to another. So let's go ahead and look back at this recipe. We are going to first convert 125 milliliters of whole milk, and we are going to change that unit of volume to a volume that we are much more comfortable with measuring. And in America, we tend to use the cup. So we are going to change the unit of milliliters of milk to cups of milk by doing dimensional analysis. So in order to do this, what you have to do first, and normally I would give this to you, sometimes I'll have you look it up, but I looked on the internet and I said, how many milliliters are in one cup? So I found this online and I found that there are 240 milliliters in one cup of some liquid. One cup of any liquid has 240 milliliters of that liquid in it. This particular item is what we call a conversion factor. So a conversion factor is just an expression that shows the relationship between two units. So because I'm converting between milliliters of milk and cups to milk, I need to know their relationship with one another. And their relationship is represented by that conversion factor, which says that 240 milliliters of milk is equivalent to 1 cup. So we call this ratio, or this equity, a conversion factor. And these conversion factors are important when we are performing dimensional analysis, but we really have to manipulate this conversion factor a little bit. And we want to represent it more as a ratio. So we know that 240 milliliters of milk is equivalent to 1 cup of milk. We can represent that in one of two ways, and we could do that by writing a ratio or a fraction. So we can say that 240 milliliters of milk is equal to 1 cup of milk. So I just did one on top of the other, or I could flip it and show that 1 cup is equal to 240 milliliters. So notice that all I did was I just put the 240 that was on top, I just switched it to the bottom. I flipped the two parts of that conversion factor and I made two fractions. And those fractions are what we are going to use to determine how we have to set up our dimensional analysis problem. Now that we have this conversion factor and we've looked at these fractions, we can start the process of the dimensional analysis. So we always want to start off with the problem or with the unit that we're given. So right here, I have 125 milliliters. That is our starting amount. That's what I want to convert out of. You'll notice that there's a little crosshair that I set up. And we are going to use that crosshair in order to aid us in solving this dimensional analysis problem. Notice that I have this starting amount in the upper left-hand corner over here. Whatever unit I have in my upper left-hand corner has to then come down to the bottom right-hand corner. And that's because mathematically speaking, those two units will cancel one another out. And we'll talk more about why as we progress through this problem. That particular unit is the unit that we want to cancel out. So that milliliters we want to get rid of because we don't want milliliters of milk anymore. We want cups of milk. The unit I want to convert to, the desired unit, is going to go on the top. So my milliliters is on the top left of one, the bottom right of another. They are diagonal from one another. The unit I want to convert to is going to go on the top. Notice that I have milliliters on the bottom and I have cups on the top in my dimensional analysis problem. I need to go back and determine which one of these fractions has the units in the correct place. So notice that I have cups in the numerator and I have milliliters in the denominator right here. Which one of these has that set up? Hopefully you would identify that the one on the right has that as the setup. So what we can do is take those numbers and plug them in to my dimensional analysis problem. So notice I'm going to put, oh, that one would cancel out, so I'll just put the X over there. But 1 cup is equal to 240 milliliters. So notice that I took this right here and I put those numbers in to my dimensional analysis problem. What this does now is those units of milliliters will cancel one another out because, again, they're opposite one another. In order to finish solving this, I'm going to have to move my picture over here. In order to finish solving this, what we would do is, and we could put a placeholder of 1 in this bottom section. I'm getting ahead of myself. We'll put a placeholder of 1. Technically, you don't need anything in that bottom right left-hand corner, but sometimes I do like to put a 1. And then I would solve. And the way I solve this particular problem, I like to multiply straight across first. So I have 125 times 1, and that gives me 125. And that's over that bottom portion. So 1 times 240 gives me 240. Once I get that, I could solve by just dividing those two numbers. So 125 divided by 240 gives me this answer. So I have 0.520833. That, although it's the correct answer, we have to make sure we express our answers to the correct number of significant figures. We are dividing here, so it looks like 125 has 3 significant figures, but this bottom number has 2 significant figures. So we want to round this answer so it has 2 significant figures. Therefore, my final answer is 0.52 cups. So the unit that my answer is, of course, is going to be whatever unit was left over at the top, since that was our desired unit. This whole entire process is the process of dimensional analysis. You have to get very comfortable with this process because this is how you're going to solve every dimensional analysis problem, is by using this technique. So we say 125 milliliters is equal to 0.52 cups. we're working in the, in the lab, but in the kitchen, you're not going to measure 0.52. We're just going to say that's about a half a cup of milk. So at this point, woohoo, you have one of your conversions done, and you can start thinking about some of the other conversions if you really want to make this recipe. Let's look at another example. So in this case, let's convert 250 grams of flour, and we're going to convert that to cups as well. So I have my unit that I want to get rid of because Americans don't use mass to measure flour. We instead use cups. So we want to convert it to units of cups. I am giving you the conversion factor in this case. So we know that 143 grams of flour is equivalent to 1 cup of flour. That's my conversion factor. So I could write 2 ratios or 2 fractions that represent this conversion factor in the same way. One way is that I could do 143 grams over 1 cup, or I could do 1 cup over 143 grams. So again, I'm just manipulating that conversion factor and doing 1 on the top and 1 on the bottom and then flipping those. Because recognizing that's going to allow us to see which one of those goes into our dimensional analysis problem. So there's our 2 fractions. Let's go ahead and start the dimensional analysis. I have 250 grams. That's the unit that I want to get rid of. That is my starting amount. So we're going to set up the crosshair just like before. And whatever unit is on top, I'm going to bring down to the lower left-hand corner. And that's because, or to the lower right-hand corner, I'm sorry. And that's because we want to mathematically cancel those units of grams out. That unit is the unit to be canceled. The unit that goes on top is the desired unit. So I want to convert this to cups. I'm going to put cups on top. Let's look at the 2 ratios that we wrote before. Which one of these ratios has the numbers in the correct spot if I have cups in the numerator and grams in the denominator? Looks like this one right here again, the one on the right, has that in the correct setup. This one is incorrect. So I could plug my numbers in to my dimensional analysis problem, cancel out my units of grams, like we said, because mathematically they cancel. If you want, but you don't have to, you can put that placeholder of 1 down in that bottom left-hand corner, and we could start to solve. Remember what I like to do, I like to multiply straight across and then divide by whatever's on the bottom. So 250 times 1 gives me 250 going across here, and 1 times 143 gives me 143. So to get my final answer, I would just divide those 2 numbers. And you'll see I get 1.748252. Remember, we can't be more precise than our least precise measurement. That 250 grams of flour in the recipe has only 2 significant figures. So we want our answer to have only 2 significant figures. So we would round this to 1.7 cups. And notice that the unit for my final answer is equivalent to whatever unit was left over in the top of my dimensional analysis problem. So again, if we were working in the kitchen and you were to have done this, 250 grams of flour is about 1.7 cups. 1.7 is a little weird. What we can say is that this could be about 1 3/4 cups, or you could even say 1 1/3 or 1 2/3 cups. And this is where baking gets a little funny with our system, because 1 3/4 is very different from 1 2/3. So something to think about. And that part's done. So we're excited. We got another unit converted out here. We can start to think more about making this delicious type of bread. So let's try the next one. We have 50 grams of butter. We don't typically measure butter in units of grams. Instead, let's go ahead and measure that in units of tablespoons. So here's the conversion factor again. So 1 tablespoon of butter is equivalent to 14 grams of butter. That's my conversion factor. And we could write our ratios out from that. So 1 tablespoon over 14 grams or 14 grams over 1 tablespoon. There they are again. Set up our dimensional analysis problem. So I have 50 grams. That's my starting amount. Whatever units on top, I'm going to bring down to the lower right-hand corner. That's the unit that's going to be canceled. Whereas the tablespoon is the desired unit that's going to go on top. Which one of those fractions represents that part in the dimensional analysis problem the best? Which one of those two fractions has tablespoons on the top? Hopefully you would notice it's the one on the left in this case. The one on the right does not have that fraction represented that we could put it in this particular problem. So I would put 1 tablespoon on top is equivalent to 14 grams goes on the bottom. And we could go ahead and solve. So again, those units of grams cancel out. We could put that placeholder of 1 down below. Notice it's the exact same procedure every time. We're not doing something different every time. It's the same exact process. And this process is really what is so important for you to understand. And that's equal to, multiply whatever's on the top, I get 50, divided by whatever's on the bottom is 14. And we get 3.571429. Remember, we can't be as precise as the least precise part of this measurement. That 50 grams actually only has one significant figure. So we would round 3.571429 to one significant figure. We would round that to 4 tablespoons actually. So 4 tablespoons of butter. Remember, whatever unit's up top, we're going to bring down and make the unit there. So 50 grams of butter is equivalent to 4 tablespoons. You can also consider how many sticks of butter is this, which we're not going to do that conversion. But if you consider a stick, 1 stick of butter is 8 tablespoons. So if you have 4 tablespoons, clearly that would be a half a stick of butter. So you're almost doing dimensional analysis. If you're cooking and you need to know how many sticks and you know how many tablespoons, and you figure out, oh, it's this many sticks, you're already doing dimensional analysis. We're just kind of taking it, giving a name to it, and making the process a little bit more streamlined so you could see how we do this with slightly more complex problems. Let's try one more. So here's another one. Let's do the mozzarella, right? I'm Italian. My dad yelled at me when I was little. I called it mozzarella. And he said, why do you call it that? And I said, I don't want to say mozzarella in front of my friends. And he says, I don't care what you say in front of your friends. You say mozzarella when you're with me. So I said, all right, you know, my maiden name is Padavano, so I got to make sure I say these Italian things the right way. Let's convert this. Last one. 50 grams of mozzarella is how many cups? Here's our conversion factor. And I just put mozz there because couldn't fit mozzarella going all the way across. But 112 grams of mozzarella is 1 cup. Let's write our fractions out. There they are, okay? One over the other, and the other one is flip-flopped. I want to get rid of 50 grams. So set up my crosshair, goes right there. Whatever, that's my starting amount. We're going to bring grams down opposite. That's my unit that's going to be canceled. My units of cups is going to go on top. Which one of these fractions is the correct one? Is it the right or is it the left? Hopefully, you would say that it is in fact the right one in this case. Those are the numbers that we need to plug them in the right part of this dimensional analysis problem. We can go ahead and cancel units of grams, add my unit of 1 as a placeholder, multiply straight across. So I have 50 divided by 112. I'm not always going to get some number over some number, so don't get comfortable with having to do the division part, one number by the other. You could have both numbers on top over 1. So just follow the process every time. Dimensional analysis is not a memorization type thing. You have to understand how to do it. And we get 0.446429, which has way too many significant figures. So 50 grams of mozzarella has 1 significant figure. So I would round that to 1 sig fig. I'm rounding it down to 0.4. And whatever unit is left is the unit of my answer. Now, something like this, of course, I love cheese, so I would probably round up. Whereas other people who might not like something super cheesy could round down. And this is the beauty of cooking, right? Is that we can change things to suit our own personal preferences. And it's all significant figures, right? Because we are able to do that. Cooking is not an exact science. Baking is, but cooking is not. Anyway, 50 grams mozzarella is 0.4 cups. If we represent this a little bit better, 50 grams is about a half a cup. Again, I would round up, so you could round down if you want to. But usually culinary, chefs and culinary artists tend to use fractions instead of decimals. And there's some cheese. So we are going to get a lot of practice with this process. So please make sure that you ask me any questions that you might have in class. I have a lot of activities that we're going to do. We are going to convert a lot during the year. I told you the first day of school, chemistry is not a topic that you can just learn something and then forget it. We have to know how to do significant figures and dimensional analysis, especially dimensional analysis, all throughout the year, because in order to do the harder chemistry, you have to know how to do something like this. This process is very important. As always, if you have any questions, please make sure you ask me. Otherwise, I will see you in class, or I will see you in the next video, which will be all about density. Bye.